Hi, this is ET370, Lecture 8, and this is going to be a four-part lecture. In the first part, we're going to talk about a simple little NMOS and PMOS tester circuit that I made. In Lecture B and C, we're going to go into practical implementations of an NMOS and PMOS. And then the last part, D, we'll actually look at a three-phase inverter. And so I think this last one will be a lot of fun, but you got to kind of watch these two here, especially to make sure you understand this one, okay? All right, let's go and look at the NMOS and PMOS tester circuit. And so all this is just a little circuit I made to make sure that the NMOS and PMOS work. Sometimes these come, dead on arrival or whatever. You just want to make sure you haven't burned it. But I made this circuit just to make sure it works, right? And so here's the NMOS version. And remember, if we look at this NMOS, we have the arrow pointing in, the opposite of an NPN. And what I have here is a little LED with a current limiting resistor. And remember, the MOSFET's acting like a switch. So on, off, and I have like my battery or power supply here. Okay, so if I turn this on, can you imagine current's going to flow through here? Now to drive it, what I have is just a little button, so a little button there, and I'm driving the gate either to a high voltage or a low voltage. Now notice I have a pull down resistor, kind of like a button to pull this voltage low so that this is always off. Now for the PMOS, it's kind of the opposite. Notice the NMOS is on the high side and the PMOS is on, or sorry, the NMOS is on the low side and the PMOS is on the high side, right? But it's the same idea. The PMOS is acting like a switch. I have an LED and a current limiting resistor. I have my voltage source, and this time I have a pull up resistor. So when the switch is open, this voltage is pulled high, which means this is turned off. Once I close the switch, now this pressure is pulled low and the PMOS activates. Remember, it's kind of inverted logic relative to each other. Okay, so if I look at the data sheet, so I'm using an IRF 3205. So this is my NMOS version. They both look the same. They're both, they call it a TO220 package, all right? And so this is the 4905. I know you can't see it. Maybe if I got closer, you could, but yeah, the focus was not so good. Okay, so 3205, 4905, and those are the two types of NMOS and PMOS that I'm using, okay? And so I labeled it actually 1, 2, 3 gate, drain, source. Remember, the gate is the input and then the drain and source are the two outputs, okay? And notice that these actually come embedded with a little flyback diode already in there, okay? Some things to note. Very low RDS on. Remember, the RDS on is the resistance when it is in that triode or fully on mode. And so this one here, the NMOS is at 8 milliohms. This is at 20 milliohms, very small. It can handle 55 volts here, and the NMOS can actually handle 110 amps, and the PMOS can handle 74 amps if you keep it cool. If you don't keep it cool, then it can burn and it can handle less current, right? And you can see all the maximum ratings here. For example, the maximum VGS you're going to want to put through here is only 20 volts, right? Same for here. Okay, now typically your Arduino microcontroller is 3.3 or 5, so it can't even go up to 20 anyways, but there is some maximum minimum ratings here, right? So this is a nice little high power MOSFET in a small little TO220 package. But let's look at the circuit implementation. So I made this circuit board in EagleCAD, and I hope you can see that these two are nearly the same, except I forgot something on here. I forgot to put the pull up and pull down resistors. And so when I printed the board, it wasn't working. Like, why is it not working? So I had to go in and solder a pull up and pull down resistor. You know, sometimes you make mistakes, but sometimes you can fix them. So I didn't reprint the board. I was like, well, if I can just jumper in a resistor, should work. Okay, so let's do a little demo here. So I have my power supply here, and I mean, it's not super exciting. All I'm gonna do is I'm gonna take my NMOS and PMOS, hook up power and ground, and notice I put ground and power so I know which one is which. So I'm gonna put ground here and power here. I'm going to turn on my power supply. So I got my little power supply here on the right here. And all I have to do is push the button and hopefully the LED turns on. And so all you want is a controlled switch. So I'm going to power on here. I have 5 volts. Okay, so hopefully this works. Yay, this works, okay? And so it's doing its job. When I don't have the button pressed, okay, this is low, okay? And when I push the button, it turns high. Okay, and we can do the same thing here. Okay, turn this off, switch the leads. This is going to be the PMOS here. So the PMOS is here and the NMOS is, or sorry, the high voltage and low voltage are here. Okay, so that's this one. And again, I power on and I push the button and yay, these both are good PMOS and NMOS circuits. And just to review, you have your LED here, your LED here, right? You have your resistor good, and you have your chip, right? And then you have your gate resistor. And like I said, I forgot this, so I had to jumper this in, and I got my switch. And then same here for the PMOS. You have your high side voltage here. You have your PMOS going down to your LED and resistor. And again, I forgot my pull up resistor, but with a little fix, it worked. Anyways, I hope you found this lecture useful. I look forward to seeing you in the next part. All right, have a great day.